Okay, I realize that I forgot to show why the limit comparison test works. And so I'm going to do that. It won't take long. And there's two key ideas. The first key idea is if the tail of the series converges, that is, if eventually at some point, the end of the series, aka converges, so does the entire series. We talked about that with the root and ratio test videos. And number two key idea is that if our series converges or diverges, so does L times that series, which we can think of as L times each term, as long as L is finite and positive. Okay, so that's the key idea. So here's the limit comparison test. We're going to be given a series, AK, and we're going to limit compare it. We're going to compare it using the limit test to BK. And for now, assume that our comparison series, our reference series, BK, converges. Okay, so I'm going to set up my limit, AK, BK, and let's say I do all the work and I get this. That the limit is finite and positive. Well, eventually, we can say that AK over BK is about equal to L, eventually past some n. And so that tells me that AK is about equal to L BK. So that would mean that my sum AK, which I'm trying to show converge or diverge. Well, in this case, I'm going to show that it converges. So this is going to about equal to the sum of L BK, which is going to be L times BK. Okay. Now this is finite and positive. So that means that we have this series converges and it's times a finite number. So this series converges. That means that this series converges. So that's the tail, and that tells us that the entire series converges. So I'm going to do that. So again, we're given AK, we're going to compare it to BK. We'll assume that BK converges. We take our limit, we get L is finite or positive. That means eventually, that's what it means to be a limit, that AK over BK is very close to L for all K. That means that AK is about equal to L times BK, where L is finite and positive. So that means that the tail of AK is about equal to this series, which is about equal to this series. This series converges. So that means that this series converges, the tail of AK, and that means that the entire series converges. So that's why. So let's go over the same thing if we get infinity, okay? So we take our AK, so we have another case that we have, let's say our L is equal to the limit, get that out of the way, AK over BK, K goes to infinity, is equal to infinity. And let's say that BK converges. Okay. What we get is we get AK over BK is this limit converges to infinity. That says that AK is very much larger than BK. That's what it means. For this to be infinity, that means the top is much, much bigger than the bottom. So that tells us that this series, AK, is much, much bigger than BK, which converges. Well, this could converge, or it could diverge. Who knows? All we know is it's much, much bigger than a convergent series, and we could also have a convergent series, which is much, much bigger, or we could have a divergent series, which is much, much bigger. By the way, this is actually does mean much, much bigger in math. That's what it's supposed to indicate, that we have, when we use this symbol, it means whatever's on this side is much, much bigger than that side. It's kind of vague. Okay. So one more thing, and then we'll be done. Again, we're given AK, and our reference series is BK. And let's say that this time BK diverges. Okay, we'll do the same thing. So we take our limit, L, and we assume it's finite and positive. Okay. And we're saying that BK, that diverges. Okay, so that tells us, well, that AK over BK is about equal to L. That tells us that AK is about equal to L of BK. That tells us that the tail of AK is about equal to L times the tail of BK, which is series LBK. Okay. L times diverge equals diverge. So therefore, this series diverges. Well, that tells us that this does too, because therefore AK does as well. Again, multiplying L times something which is divergence, it doesn't change anything. It still diverges. Okay, hope that helps.